Hi, math lovers. We're going to talk today about sets and real numbers. Through our notes, let me give you a couple important things to talk about. First is finite and infinite. So we talk about terms as being finite because there's an end to it, and infinite. You've heard these words used before. Buzz Lightyear, to infinity and beyond. He goes on and on forever and ever and ever. So if you take a look at your sets here, notice that this set here in that letter A, that's ending. It's ending at 14. And set B, I think I had a little, I think this is 3 dots here at the end. That goes on forever and ever and ever. What's new to us, though, is this notation. We're in college algebra now, so it's college. We have to use the fancy notation for our set. So what it's saying here, this set says, this is our variable. The variable that we're going to use, it's just telling me, hey, I'm going to use X. And it's giving me a definition. It's a fraction between 1 and 2. You know, there are infinitely many terms between 1 and 2. If I had written it like this, where I said X is between 1 and 2, right? You'd be fine with that. But now we're using set notation, okay? Moving on to look at a couple different ones. Let's skip here to, let's skip. Here we go. It's the subsets, okay? Subset is part of a set. A subset is part of a set. And there's a new notation we're going to use. We're going to use this subset notation. It's a little letter C with a line underneath. Don't confuse that with a less than sign. So it's giving you 2 sets here. The first one is the universal set, and they use the letter U. That's the whole set that we're talking about, okay? Universal set. It's everything we begin with. And then I can make a couple other sets. They're giving me set A, set B, and set C here. Oh, and even D. It says determine whether each statement is true or false. Okay, so let's go through what I have here. So we're looking at those sets. It says here, D is a subset of B, and that's exactly how you'll read it. D is a subset of B. When you see it over here, you'll say in letter B, you'll say B is a subset of D. So you're going to see if every single thing in D is also in B. Okay, yeah, everything in D is in B. You see 1 and 9, and then you look at B, 1 and 9, there it is. So you know that it's a subset. Let me clean this up for us. Put too many dots in there. B, is everything in B also in D? Is everything in B in D? Is that true? No, it's not. That is not a subset. Therefore, it is false. Okay. Then I have the notation here, not a subset. It's just a little letter C with a line through it, and it's not. You're really familiar with that symbol with an equal sign, and then if it's not equal to, you put a symbol through it. You guys are familiar with those. So not a subset. So what I'm saying here is C, not a subset of A. Well, let's see. This is awkward because C is a subset of A, so that's why I say it is false. Okay. Moving on to other notation. This is what's called a complement. So a complement is the other part, the part that's not in it. So we would say A prime, and this is the way you're going to say it, A prime. It's got a little hash mark next to it. It says the element is not in A. So if I say to you, hey, here's the universal set, 1 through 7, universal, that's all the ones we have to pick from. 1, 3, 5, and 7. So notice that I have 1, 3, 5, and 7. So now I want to know the complement. What is this set that if I take this set, the complement, and I add it to my original set A, I will be left with the whole universal set. So that would give me 6. Let's see, I've got the 2 here, I've got the 4 here, and I've got the 6. What's beautiful about set notation is you never have to worry about the order, okay? Next one, letter B says B prime. So tell me, what is in? All right, start over again. Okay, so we're talking about operations on our sets. We're talking about the complements. If I take my set and my complement and I add that together, I should get the universal set. So taking a look at R prime, or excuse me, B prime here, B prime here. So I'm looking at what is in this universal set that I have B. It's 3, 4, and 6. So I have 3, 4, and 6. So what I need to do, let me erase all this. Oops. Okay. Oh, there we go. Oh, scared me for a second. 3, 4, and 6. So if I take a look at 3, I already have a 3. I already have a 4, and I already have a 6. So you can see that complement are the elements that I don't have. So that's the other set. Okay, let's skip down and try some other problems. I want to talk about disjoint sets and disjoint sets with union and intersection. So there are different kinds of ways we can make our graph look. The first one is a graph. This is an intersection. This first graph here, this is an intersection. So this is the symbol. It's A intersect B. Oh, you can't even see it because, oh, sorry, that's my fault. So A intersect B. Okay, A intersect B. They overlap. This is the section here that they both cover. If the two sets do not intersect, so let me draw you a different one. I could have set A, which is B here. I could have set B here, and there's nothing that's shared. Let me give you an example. I have set A, which is the lacrosse team, and set B, which is the golf team. There's nobody who plays lacrosse and golf. So this would be considered a disjoint set, or we call that mutually exclusive. You guys that are in AP Stat, we call it mutually exclusive in our statistics class. The other thing we talk about today is union. Union is the overlap where everything that's in A and everything that's in B. So I have all these items shaded together, okay? Union and intersection. So looking at this first one, I have intersection, letter B. I have the intersection of the first set and the second set. So I want to find where there's the overlap. Notice in the second set, there's nothing that overlaps. So I use the empty set symbol. You can use either the empty set symbol or you can use the null set, either of those. Union, you're just sticking the two sets together to find out what you have. Be sure you don't repeat your sets. Okay, again, the symbols for union and intersection.